Alright, microphone should be working now. Can you hear me? Yeah, that's extremely heavy rain. It looks like fog. The storm is rotating a little bit, but they're pretty much capped off by the high pressure, so they won't be able to do much. As you can see on the nearest video camera here, this is at Route 50 and Route 90. People have their flashers on and it is pouring rain to the point where it looks like it's fog. So basically it's like a tropical downpour. Let me pull the beach cams up. So if you're headed to Ocean City right now, you're going to have to drive through this. These little storms have popped up due to a sea breeze effect, which is like a small boundary layer in the atmosphere that forms from the difference in the colder water and the warm air. It's been moving inland off of the beaches towards the Chesapeake Bay for a couple hours now, and that is, one layer moving in one direction and then the opposite layer moving against it, above it, causes a little convection. Can really squeeze the water out of these storms and cause them to rotate, but it's probably putting out a little bit of hail. We can check and see. It's only moving about 10 or 15 miles an hour, and that's going to be the case most of the day. So here's the storm right along Route 50 between Salisbury and Ocean City in the Ocean Pines area and up to the Delaware line. And if we put that in motion and back out a little bit, you can see that sea breeze effect is this green line you can see here moving to the west. And that's basically the cold 60-some degree ocean temperature, air temperatures at the surface, and then the hotter air above caused that rolling boundary layer to move inland. Meanwhile, the prevailing winds over top are pushing storms out to the ocean, and when they combine right over top of where it's warm and humid, right down the middle of the peninsula, is where these storms fired up. So intense lightning for a minute, and then it's pretty much stopped already, and it's raining itself out. There's nothing up at Elkton so far. We can take a look around. We still have our air quality alerts flashing. That's what the orange and red is here. It's for air quality alert. And it's really coming down on that camera. People are slowing down on Route 50 there, so flood warnings because of these storms have so much potential rain over the next couple days. Flash flood watches, I should say. And then we've got more storms out in the other side of the mountains where it's also very warm and humid. And those are moving the same direction very slowly. Very small, very powerfully flooding ability. So hopefully we don't have that happen again out there. But nothing in central Maryland around Baltimore and DC right now. But there is a secondary sea breeze effect that comes off of the bay. And that's what this noise is right here in the DC area. This is probably going to fire up storms in the next hour or two as these cells and this energy that's crossing the mountains now run into this probably around 4 o'clock, 5 o'clock. We'll see these cells just flare up suddenly all along the eastern side of the mountains in the Appalachian Trail. This is typical summertime pattern. And then the sea breeze effect if we change to the Dover radar, it's almost over to the bay, and that could still fire off more cells as it gets across the bay. So these cells can fire up just as randomly as this one did. So it gives it a little bit of a spin and a little bit of a bump in convection, enough to fire off a severe thunderstorm. But this has already lost its severe thunderstorm warning. It's not even putting out lightning. Sierra, probably this could happen again. Usually there's a couple cycles of this through the evening. So, and it's going to go on probably off and on. It's just this is the mechanism that causes these random cells to fire up. And it's usually wherever the hot spots are in the land, typically down the middle of the Dover area to Salisbury area is where we see these storms fire up in the summertime when it gets above 85 degrees, 80 degrees, and the humidity's up like it is today. So the rain will stop in another hour probably, because it's so slow moving, and then we'll have a break for a while, and then another storm will pop up randomly somewhere. It may not be here, it may be Chincoteague or up in Rehoboth, very small concentrated areas. You can see that if you look closely, that storm is moving to the northeast, and then makes a complete right turn and heads south. Meanwhile, this one comes out of nowhere in Salisbury, right along Route 50, and then stops almost completely dead before it gets to Ocean Pines, and then they collide. It's weird how these things work, and they just randomly move around depending upon the prevailing winds up in the upper atmosphere, if they can reach that high, and whatever's happening at ground level, which can be all kinds of surface motions and swirls. So they're not real dangerous. When they first form, they put out a lot of lightning, and they may even dump some hail. And then they kind of rain themselves out, because this high pressure that's keeping the air low to the ground and causing the ozone problems are also capping these storms and keeping them from becoming extremely severe. So this is about the level they'll reach today at the most. They might get a little bit meaner until 7, 8 o'clock, and they'll also be moving very slow. Anything that does form 10 or 15 miles an hour in random directions, and they will be dumping microbursts. They could be dumping hail as they reach that capped off height of their maximum growth potential that's limited today due to the high pressure. So it would be a lot of orange flashy boxes for your runner-up bronze special second place for a severe thunderstorm. Not quite strong enough to qualify for a severe thunderstorm warning. And same thing's happening out here east at 10 miles per hour, which is excessively slow, and then gusts to 40 with pea-sized hail, and then they rain themselves out. So we'll be seeing this the next 4 or 5 hours randomly across the state of Maryland, Delaware, southern PA, and northern Virginia. But it's not going to be one of those days where we get random tornado warnings everywhere. We could see a tornado warning off of one of these because they tend to spin as they move so slow. But the biggest, heaviest problem will be heavy rain from these. So it's not going to be bad. It won't be anywhere near like it has been lately. It's just going to be a lot of lightning and a lot of heavy rain more than anything. But I'm going to keep this up live for the next couple hours. I'll be here watching. There's some stuff going on in the North Carolina, Virginia Beach area, Tidewater region they call that, from Kitty Hawk to Virginia Beach. And then out in the mountains there's a bunch of cells that are fired up, you can see here, and they're moving just as slow, 10 or 15 miles an hour, so it's going to take all day for them to get anywhere. It's not like these are racing across the countryside like we normally see. So now that cell was canceled for a severe thunderstorm warning in the Ocean Pines, Ocean City area, and they have since added back the runner-up severe thunderstorm warning, still moving at 10 miles per hour. So at 9 miles west of Ocean City, moving at 10 miles per hour, it's going to take an hour to get from Ocean Pines to Ocean City. Like if you were walking across the bridge or jogging across the Route 90 bridge, that's how long this is going to take. It's going to be very slow, and it may be growing more than it is actually moving. These storms will puff up and down and puff in and out in their size and their ability to create heavy rain like you're seeing on the cam there, and then they will rain themselves out, or if they do get a bit of hail going, they're capped off by the high pressure and they can't grow to 60,000 feet like normal thunderstorms. They're capped off at 20 or 30,000 feet, and when they hit that height, they just dump out, and we get a microburst and some hail out of it, and then the storm shrinks down as it rains itself out, and then it'll start growing back again, back and forth over hours. So that's the cycle that we see in the summertime, you know, and they flirt back and forth right on the edge of the severe thunderstorm warning, and they keep those meteorologists at the NWS on their toes. But they're not a huge threat. You could see a tornado warning only because they rotate, but it would be a slow rotation, barely weak enough to qualify. And then what happens is they'll scan it and they'll look closer at it with the radars and determine, well, it's not doing anything. It's probably not having an effect on the area underneath. There's no debris on the radar, and it's not a huge storm with high wind speeds, because we can determine that by the radar. And then they'll cancel it, and that's why we get a lot of those tornado warnings with cancellations with nothing that comes of it. That's 99% of our tornado warnings and our tornadoes. It seems like we're having an outbreak because we get 4 or 5 of them on a day like today, but nothing happens. It's just the computer has detected a possible tornado rotation in a storm, and then it sets off the warning automatically to give people as much as warning as possible, you know, out of an abundance of caution. And then the local meteorologist will scan it and look closer at it, just like I'm about to do right now, and I'll show you. So we can pull up this radar, and I can look inside the storm at the velocities, and these colors tell me the Dover radar is where we're at right here. You can see it radially making a pattern, and we're scanning that storm with that radar. This is velocity radar. This doesn't tell us the thickness of the clouds with the oranges and the reds and the scary colors. This tells us the wind speeds and the direction they're moving, and we can determine what's happening with the wind in that system. So right here we have a bright red, and then we have some blues. We'll put it in motion. The last 14 frames is more than enough of the radar scans, and that puts a little movie together for us to see how it's working. It's like taking a time-lapse photo every 10 seconds or every 30 seconds of the storm's development, and then we can speed it up and kind of realize what's happening. So it is rotating, but it's very slow rotation, just a little bit right there. And then what we do is we see a little bit of rotation, but it's very slow. It may be producing a low-hanging, scary-looking funnel cloud, but it's not going to be damaging winds at this level. At this level, these wind speeds are returning about 20 to 40 miles per hour. The blues are moving away from the radar, the reds are moving towards the radar. Now, it could tighten up a little bit, and that's what kind of this noise is here. And as it goes from the dark, deep reds to a brighter orange, if it's coinciding with a blue in that same area, that could be a tornado couplet. And that signifies rotation, because the blues are moving away at 30-40 miles an hour, but right next to it and touching in that same pixelated area would be oranges or brighter colors. And that's how we can determine if a tornado rotation is happening in the sky. The limitation is the further away from the radar, the higher up into the sky we are looking. So there's an angle involved here. At ground level, that tower is 100 feet tall, and it's looking out at 0.5 or 0.3 degrees. So every 10 or 15 miles, it's another 1,000 feet in the air we're looking. And the further away you get from the radar, the higher it gets up into the storm. So there's things you got to know there. However, there's another type of radar that we can use. If we do see a rotation that does look like it may be causing something happening, we can change to the correlation coefficient radar. And this radar uses algorithms to determine what is happening in the storm by the size of the debris and raindrops, hail, and things flying around in the sky. So, as we know, a tornado is a big vacuum. If it starts damaging things, even if it's a mild tornado, an EF0, EF1, it's going to be pulling leaves and limbs up into the sky and trash off the ground. If it hits a structure and damages it, in the more advanced tornadoes, it starts pulling shingles and pieces of wood and chunks and dirt, debris flying around in there. And then on the larger tornadoes out in the Midwest, it becomes very obvious when they're very strong, and you'll see a tornado vortex signature that's very bright and very obvious on the radar, which would be two of the most brightest colors on that scale, opposite of each other and touching each other. And then what happens is, in the same spot, we see what's called a dropout on the correlation coefficient. So there's nothing happening here, it's just a rotating storm. And what we're looking for, what we would be looking for, is a blue or a clear opening, yellowish opening in where the rotation is located. And that would indicate that it's a tornado on the ground. So these are things to know. And understanding the structure of the storm itself. So if this were a correlation coefficient showing a debris ball, I can draw it up for you real quick. What we would have is a big yellow area, kind of like this. Usually it's a pretty good circle, and then it'll have blues in the center. And when you see the correlation coefficient show something like this on the screen in the proper location, what you do is you then go back to to identify a tornado, even our weak tornadoes here, but you go to the velocity and you can see the storm is rotating and it does have a couplet, but this is a very weak, unorganized tornado couplet, if it were one, which it's not yet. It could produce one, of course. It's always possible, especially as it gets closer to the water, it can rotate. But what you're seeing here is the reds are moving away from the radar and the blues are towards, or actually I have it the opposite. So the reds are moving back towards the radar, but the whole storm is moving away towards Ocean City. There's a secondary radar that we can use called a high-res storm relative velocity. What that does is it accounts for it. So we may see a tornado warning on this now because it's organized enough. It's organized itself enough over the Germantown area, the Assateague Road neighborhood, Trapper Road, off of 113 here, the Pomona Heights neighborhood, the New Bethel Church by Trap Road, Teagle Drive, Germantown Road. You're probably seeing some scary looking clouds overhead, if you can see anything at all because of the heavy rain. But if you look at the camera back up at 50 and Route 90, it's already clear, sun's coming back out. So we're down from 50 towards Snow Hill, and this storm is rotating slowly. It's not enough to be concerned about yet, but it is rotating, so it's going to look like that mothership shape, and it's going to have some scary clouds. I'm trying to find a camera in the Ocean City area real quick. Let me pull that up. That's looking back that way. I would say probably this one right here, which is the big traffic cam. So it's just showing rain on it. And the Route 50 cams, I think I can do one here. So let's look at those. 60-foot road. It's clear, it's not even wet. US 50 at 90, where we were just at. Sun's coming out. If we look west at the same intersection, pretty much the same thing. Trees aren't even moving around. Trees aren't blowing around. We move up to the next intersection, 115 or 113 at Route 50, which is right here on the screen. So right here at the Berlin intersection there is where that camera is showing up in the corner. And you can see the skies are already cleared off and it's almost done raining. So it's a very, very constrained, very small storm. I didn't see anything like that. It was probably winds, like a gust front wind blowing out of the front of it, where it, and you see that on the correlation coefficient a lot on the front edge of the storm, where it's blowing up dust and stuff like that in front of it. So it does look like it's trying to, yeah, that's probably just noise more than anything. But it could be, it's hard to say. It's moving so slow that it's possible, but I'm not seeing anything on the cameras besides heavy rain, so it would be rain wrapped. But if we look back at, well, I guess let's do the high res. I try to compare the high res standard velocity and then look at the relative velocity, which takes out the storm motion, but this is not really moving, so it's not doing much. But it's definitely rotating up in the sky, but it's very slow speeds. I mean, we're talking maybe 30-40 miles an hour, so that's not really enough to do damage. It's enough to blow trash around, and it's enough to maybe break some pine tree limbs because they're weaker. But what you see there is, for a brief second, it did show a lot of wind speed, and that could be a microburst. So if it had a hail microburst, it can look like a tornado on the radar, and I'll show you the difference. A hail microburst comes from the center of the storm where the hail core is. Tornadoes come from the southwest edge usually. So if this storm was moving in this direction, your hail core would be here, and the hail's dumping out, and the winds are going to come out in each direction, but your inflow notch would be here. So the green edge of your storm, or the reds and yellows if you're on that other velocity, all this green here on the velocity would be notched right where this is. And then you would have your hail core in the center there. So if we would flip it to hydrometer classification, it'll show us a hail core. So there's our hail core, the bright reds. And it does have a bit of a notch. So the inflow would come in from the front. The rear flank downdraft blows out of the back. And this is just basic. So here's your hail. Well, let me change color. We'll do blue for hail. Here's your hail core. As that hail dumps out, it blows out. And we get microbursts. See, now the hail's gone. But it would be pulling air in if it was a tornado. And you would get a little notch like this in the storm. And then you would have your red colors coming in like this. And then the blues, the lighter blues of the velocity radar would be wrapped around the hail core and coming in. And then you would get a couplet here. And that would be that bright colored red versus a bright colored blue on my radar, or on the green radar. It would be a bright colored green and a bright colored red touching each other in a single block point. So it wrapped up for a second, but when they microburst out, they can cause little gustnados and tornadoes. The motion west to east on a standard tornado forming supercell would be your direction. Oh, let me change that back. So your whole storm is moving in this direction, west to east. It's the easiest way to remember and the way they teach it in school. You have your bright red hail cores on the hydrometer classification. Would look like this on the backside of the storm or in the center of the storm. And then you will have on the velocity matching radar, if you switch from correlation coefficient or any other radar hydrometer classification to velocity radar, what you would see is a little bit of a notch in the storm. So all of this storm would be filled in over here as it pulls the storm around the inflow. And then you get a little V notch here for a forward flank downdraft. And then you would have the blues like this and the reds, the bright reds on top of that. As they come around. So as the whole system moves to the east, you'll have these structures on a tornado that's damaging, strong enough to damage. It'll be organized enough, typically, and about this size overall on the whole storm. But the whole storm itself will be much larger, much more organized, and much higher in the sky. So it's moving offshore. It's trying to tap in to that difference in the air column, but it's already losing its hail. It may recycle though. Let's back it up a whole bunch of frames and watch just the hail. So 30 frames ago, it forms over here. It starts going to the northeast because what happens is that sea breeze hits it. That sea breeze effect collides with the very warm thermals coming up off the ground here down the center of the island, or I'm sorry, peninsula of the Delmarva. The warmest air is right down the middle always. So all that hot air is rising from the sun heating it. And that heating, that solar heating, reaches its peak at 3 to 4 o'clock. That's magic hour. So now it's starting to reform. And what happened was, because we're looking down at it from the top down, the echo heights are going to be real shallow because the high pressure is capping it. And the capping action keeps the storm from growing into a organized supercell. So what's happening is it's bumping into that ceiling limit and it dumps all the hail out. It loses and stumbles itself, and then it has to regrow again. And we get that puffing up in strength and then back down, up in strength and back down. And that's where we get microbursts and downbursts from this time of year because of the capping pressure. So a high pressure overhead storm, if the cap is high enough in the atmosphere, they can grow pretty big. But today it's pretty low. That's why we have air quality alerts. So where is my echo height? There it is, echo tops. And we are barely at 30. Yeah, we're topping out at 35,000 feet. So that's just enough to be able to make microbursts and some decent small hail and get a severe warning by generating a 60-mile-per-hour wind gust when that hail dumps out of that storm. If you've ever dumped a bucket out onto dry dirt, a bucket of water, and you see that dirt fly up in random directions, it's the same exact thing that happens on a grander scale in the microburst and downburst situation. Microburst is more focused and smaller, street-sized to neighborhood-sized. The downburst comes dumping out of the storm in every direction, and that's when the mushroom clouds hit that cap, and usually that cap is higher, up 45,000, 50,000 feet. And they bump into that, and then the storm will actually physically collapse down onto itself, like a souffle that popped in the oven. And on the time lapse, if you ever film one at a distance, out over the bay, over a couple of hours, in the summertime you can see that happen. They billow up, and they billow up, and they billow up, and then they hit that cap, smack. They dump all the hail out, and we get a big circular downburst in all directions. It happened last year over the Severna Park area. It was like a 30-mile wide area. Did a lot of damage up there between Annapolis and Baltimore. And what happens is the cells will lean forwards or lean over, or they'll collapse down on themselves. And it's fascinating to watch on a time lapse. But this one, you can see it's trying to grow. It grows. It got pretty big, and bang, it ran into that cap, and then it fell. Let me slow it down because that's pretty fast. Turn your animation speed way down, and you can see it better. So let's dual screen it, and I'll give you a class on this. So on this left side we have the echo tops, the maximum heights of the storm. on the right side, we'll do standard radar reflectivity. And then you can see the sea breeze is right here on the right side. It's more pronounced, and that line runs from here and starts moving over, and when it gets to the center of the Delmarva Peninsula, where the hottest air is at this time of day, at magic hour, 3 to 4 o'clock, it collides with those columns of thermals that you see the birds riding around all day, and bang, the storm is born. Same thing up here. It starts to grow, it gets a little ahead of itself, and it turns, it makes a right turn. So here it goes, going northeast, bang, it stops, makes a right, collides with this other storm. It was putting out good lightning, it stopped making lightning, now it's regrowing and regenerating again after it ran into that cap, that ceiling height limit, and it got less dark reds in it and thinned all out as it started to rain itself out. Energy transferred down to the other cell, and now it's starting to grow. And if you look on the Ocean City camera, it's pretty heavy rain to the south inlet area. If you go to OC Maryland, OCMD webcams, and I can pull that up. Whitney, where at? You guys are like, what, Harper's Ferry area? You guys should be okay. Nothing's going to get out of hand today too much. What's happening over here in the mountains is the same effect, but it's a line of energy along the Alleghenies. And what's happening here is the height of the Alleghenies, and that big ridge line is blowing the west to east winds across the land, and it's making it rise suddenly. And that upsloping orographic lift effect is causing storms to form over and over in that area. If I put it in motion, same thing. So you can see the ridge lines, the striations on the map. This is an actual image map. And you can see they're growing right as they run and thickening up right as they run into those mountains. You can see the mountain lines right there. And they're forming out of thin air because that wind is coming across it's only 500 feet to 1,000 feet above sea level, most of the Ohio Valley. And then what happens is the winds race across here 20-30 miles an hour, and they run into these 3,000 4,000 foot mountain peaks, and they have to go up to get over them. And that sudden turn to the higher altitudes and the climb makes the air colder and more dense, and anytime you squeeze air, water comes out of it. And that's the process that's causing these storms over here. So these storms are kind of going to rain themselves out and regenerate, over the hours. They're not really going to make it over into the Baltimore area as much. Oh, good Lord. Sound like somebody wrecked out front. Just checking my cameras. But that was loud. But anyway, so these are standard summertime typical storm effects that we see in the afternoons pretty much every day that it's warm and humid enough. So if we shorten this back up to 21 frames is where I like to keep it. And that shows us about an hour and a half's worth of development. So not a lot of lightning. Same thing's happening. They're flaring up, just like the Ocean City storm did. And then they run into that capping effect of the high pressure at a certain altitude, which you can calculate on the calculator if you know all the parameters, dew points and humidity and all that. And then that'll tell you the cloud height, and that's the capping effect. And when the storms reach that, they kind of bounce back off of it, collapse back down on themselves. So they're only moving about 10 to 15 miles an hour, if at all. You can see this Chincoteague storm is basically just reforming in the same spot over and over. And that's because there's a hot spot there that started it, you know, from this strip of water being so close. Now water is about 70-some degrees on the Pocomoke Sound side, and it's much cooler on this side. And as it crosses the very thin barrier island, basically is what these are, giant barrier islands. This strip down here south of the Virginia line, same effect is happening. The air is coming across, it's nice and warm and humid, picking up bay water. Suddenly it's over dry, hotter air from the land, the sun heating the land, and you're getting that reforming storm over and over again in the same spot. This will probably start happening up here in Ocean City as well. It's probably going to rain for a couple hours, but it's not really putting out a whole lot of lightning at this point. But this one looks like it's setting up for a while too, so this could go on till 9, 10, 11 o'clock tonight, and more can form. But they're not going to be super dangerous. You could see a tornado warning out of them, but just keep in mind that this is not a Midwest tornado situation. This is a Maryland. 99% of the time it's a false alarm, and that 1% is still only usually a EF0 to EF1, very weak, minimal tornado that only lasts for a few minutes. And that's typical of the area. So we've got two sea breeze effects going on, and we get that this time of year. One off of the ocean, and that's what formed these cells here. You'll see that in just a second when it starts over. No, it's not showing up now. I'm on the wrong radar. So we've got this sea breeze effect here running into the bay now, but it started over here. And these things actually start right along the beaches. You'll see them develop around noon to 2 o'clock, and they're invisible in the air. It's only on the radar that sees it, because it's a boundary where the air changes. So it slows the radar down, and the radar detects it as a cloud, even though there's nothing actually visible. But the denser air slows the radar return down, and it shows a return. As that moves along to the west, and they go random directions and they snake along, they're moving very slow. That's what created these storms, because the prevailing winds are blowing to the east, and then the sea breeze effect is moving towards the inlands, opposite direction. And when you have that collision, it spins and rotates, and you get a little convection out of it. If we change over to the Sterling radar, and put that in motion, and you'll see the same thing coming off the bay. It's already over here. So the DC corridor, and then there's a storm kicking up, just starting to fire up off of that, and they'll rain themselves out quickly. But the lower Potomac River from Washington DC all the way up by the dam past the Theodore Roosevelt Island up here is tidal basin. Oops. So there's the dam, Snake Island Dam, and that's the radar making the blotches, but that's the Potomac River Dam, Washington Aqueduct System, Falls Pump Station, and these falls are the fall line from here down right to downtown DC, to where you get the cherry blossoms and Foggy Bottom, Georgetown Waterfront Park. This is tidal basin, believe it or not. all the way up in this Potomac this far is technically tidal and rises and falls with the moon and everything. And that's because of that fall line that 95 rides along. So from here down, it's at sea level, all the way down past Quantico, all the way back around to Colonial Beach and out to the Chesapeake Bay. And that area right there is the hottest area and most humid always, from Washington, D.C. south along the Potomac River all the way down to the Chesapeake Bay. We get a lot of storms form here, and we get a lot of tornado warnings that form here because of the unique features. From Washington, D.C. north, it's all in the mountains, as you can see, cut through the mountains, and there's a lot of rapids and stuff like that. So a lot of times these storms need to be going at least 35, 40 miles an hour to make it across the mountains, but they can also be packing a lot of energy due to an extreme difference in the boundary layer from one side to the other. So there's a lot of variables there as to why they do and why they don't make it across the mountains, but there's the derecho effect where you get an MCV, MCS type storm that just has that focused bow echo energy that just keeps going for some reason. But these storms and the cap are going to keep them from becoming too vicious and making it very far. But more will start forming here shortly. This is just the first stages of the afternoon. As the afternoon progresses and the temperatures get higher and the dew points climb, we'll see more storms pop up usually. But this is the first day, and you may remember in a post I said a couple days ago, things have changed, and these low pressure systems, these winter style storms, should slow down as we transition more into this derecho type setup and summertime typical thunderstorms around here, where you just get the isolated supercells like we have today. And you can see they're streaming off to the distance. It looks almost like a smoke trail. So these are going to keep going on, and they'll keep drifting down and back, and they'll disappear and come back, disappear and come back for the next 4 or 5 hours. But they'll stay at this level. They may flare up temporarily, but they're going to run into that cap, and then they'll fall flat on their face. Same thing out in the mountains. We may see more severe thunderstorm warnings, but usually it's only right around 2 or 3 o'clock when that happens in this type of setup. And then we get to tropical storms and nor'easter type setups where the prevailing winds are backwards and they blow in and against the mountains. And then that's when we get the big rain. And that's probably is what's going to happen tomorrow night, because they're talking about a low pressure here, which is why the flood warning is here. And then another one out in the mountains again. So we'll have a big low here, and then out in Ohio, another one out here. And we'll get that heavy rain in between them. As this one moves, it'll go this direction. And this one between the mountains, or along the mountains I should say, and then in between the Great Lakes and the mountains. And when these low pressures track like this, it's a Miller type system. This is technically a nor'easter, but it can be tropical too, but regardless. So we get a transfer of energy from the inland low to the outboard low along the coast, the coastal low. And in that scenario, there's also a big component, and that's the Gulf Stream out here, the water. It's almost 62 degrees at the Ocean City area, 65 degrees along the coast, but you go out and it's cold, deep water. But then you get out here about 100 miles or more, and you've got the Gulf Current, rolling through there 80 some degrees, which I should pull the windy app up and see what that is right now. Let's see what our water temperatures are for the weekend. I know a lot of people are interested in that. You go to the windy app and you can pull up the sea temperatures. In the menu. Excuse me, losing my voice again. This thing does not want to work today. So you have all these different maps to choose from. Where is it? There it is. Sea temperature. So Ocean City, out in the on the beach side, 69 degrees. Out in the bay, about the same. It depends on which way the winds are blowing. That can change drastically in 2 days. I've seen it go down to 59 degrees because of the cold water being welled up from the ocean. But now look, the bay is much warmer. Chesapeake Bay, 76 degrees already, which is quite warm in the lower bay. The Potomac River Basin, about the same, a little warmer the further up you get, the more shallow it is, but the colder it gets when you get towards DC. But the slow moving, I mean, there's dolphins and stuff out here already in the Potomac. So all the way up the bay by Baltimore, 74 degrees around the north side of Kent Island, 75 on the south side of Kent Island, and it picks up quickly. 76 by Point Lookout, Calvert Cliffs, down around Tillman Island and all. 77. So these temperatures have been climbing fast. And now that they're above 70 degrees, it flips the way the bay works on storms. And it used to cancel all the way up until about a month ago. It would cancel out the storms as they tried to cross. Now it's going to start flaring those storms up as they move from west to east. So when we get storms come out of the mountains, they flare up around Frederick and Hampstead, Carroll County, Westminster, Germantown, Gaithersburg, and we get some little tornado spin-ups when they're strong. And then they kind of rain themselves out as they move towards the bay. And then we would get some cancellation effect from the colder water of the bay. Well, now, as those storms start falling apart and they get out over the bay, they're going to flare back up, even if it's at nighttime, because the bay is so warm. Down on the lower end, 70, it's usually the warmest right around the Potomac, which is why dolphins and whales and stuff are always down around there. 77, 76. Yep. And then the rivers get quite warm. In Virginia, 79, almost 80 degrees. You move down to Virginia Beach and Kitty Hawk, 75, 73, it's colder, but 78 on the other side of the Bay Islands. But now look at this. This is the bane of our existence here in Maryland, the Gulf Stream current. 81 degrees. It would cancel the colder water of the bays. When the temperatures are lower, it sucks the energy out because heat wants to transfer and even out. Browning type effect. And, all things want to come to a even rest. So when you have a high pressure and a low pressure, you get strong winds. The stronger they are, the stronger the winds are, because those forces are trying to cancel out. Same thing with the water in the bay. So before the storm disturbances would come across, it would help suck the life out of them as that energy would transfer into the bay water. But now it's an additive force, and usually sometime around Memorial Day weekend to Father's Day is when that happens. So now we're on the additive force side, and that's probably what's powering these storms. Now we've got a flood advisory here for Route 50 corridor, Berlin, Route 90, 589, Ocean Pines, Germantown, almost down to Hayes Landing and the airport there, down by Snow Hill and all. And this is because it's just going to be pouring rain here constantly, and it is definitely pouring the rain. But so the big additive force here is this Gulf Stream current, and it's crazy because if you look off the coast of Ocean City, the further out you get, the colder the water gets. 69, it starts turning greenish. 100 miles out, 66. But as you can see, these little lines show the flow of the current. And so we get a cold swirl here, and then on the hot side, 80 degrees, 81 degrees. The further south you go, the hotter it gets. So off of the North Carolina coast, 81, 83, 82, 82. Then we get down further to the South Carolina coast, where the bend is by Florida and South Carolina and Georgia, 83 degrees. 83 degrees. That's enough to support a 84 by Florida's coast, a hurricane formation. This water in this current in the dead of February, the end of February, is still 72, 73 degrees. And that's why we get those nor'easters forming right off the Virginia and Delmarva area, because that water temperature difference and that low pressure energy gets in this area, and it just drops like a cyclone forms, cold core or warm core, it doesn't matter, it's all the same. A big mesocyclone sets up, it starts spinning around the low pressure, and then as the onshore flow side feeds in, just like with a hurricane, there's a dirty side, and it forms these thunderstorms out over the ocean 100 plus miles out, because that 70-some degree water is still out there feeding it. And then they come on shore, where on the backside, the air is being pulled down behind the low, and we could be 30 degrees or less in the end of February, even in March. And that's how a blizzard forms, because those summertime style thunderstorms form on the east side because of this Gulf Stream current, and then they come slamming into that cold air that's still over the Delmarva. Well, not the Delmarva is usually rain in a nor'easter, and then we get that line that sets up to the northwest corner, right here where the line for Washington D.C. stops and Maryland starts, and it's 400 at Renko Park. It's like 450 feet or 405 feet above sea level in 5 miles. So all this unique landmass is what causes our weather to be so funky, and this is why we have so many unique setups here, because of the Chesapeake Bay, the Delaware Bay, the ocean, and the mountains being all so close to each other. So that's my lesson for the day. I'm tired. The reason we're getting all of these air warnings is because of the high pressure. It's pushing the ozone down. But this will be over tonight. 117 ozone to lift and the air back up. And severe thunderstorms anywhere else over the same spot. But anytime due to those storms, it wants to spin in a counterclockwise pattern on this side of the planet. If it was on the southern half below the south side of the equator, then it would spin clockwise. So this is going to go on this afternoon. We may get more severe thunderstorm warnings, but after about, well, what time is it now? We're right at the end of magic hour. We could see more severe thunderstorm warnings between now and I'd say 7, 8 o'clock at the latest. But usually around 6 o'clock in this pattern, in this type of setup, they'll start falling off quickly, even if they are a bunch around. And we don't have any tornadoes yet out west, and only one severe thunderstorm warning in the whole country right now. So finally a calm day so far. That may change quickly. Out in the Midwest, you may have noticed that the severe thunderstorm threat and the tornadoes early spring happen in northern Texas and Oklahoma, Kansas, and then also they stream off to the east along the Mississippi River to the Ohio Valley, the secondary part of the Tornado Valley, or Tornado Alley, I should say. And then suddenly around this time of year, which is just what happened, it changes up into Nebraska and North Dakota, South Dakota, and further into Montana and stuff like that region, because it's colder up there, so it takes longer to warm up the higher north you are on the planet, and that's why we get these cells. I watched a tornado happen out here the other night, right by the big mountain. And that's all Yellowstone and stuff up there, so there's Yellowstone right here, the big volcano area. Then the Colorado Rockies and all that. They're much, much higher mountains, so cause a lot more drastic. But you can see here, same thing's happening out here right now. The mountains are showing on the returns. The radar's nestled down in the valley, and the mountains are much higher all around it. And it's mountains are causing the same kind of effect to happen here and over here. Just reforming storms. But they can get big tornadoes out there. And the chasers are probably up there today watching it. One. So yeah, not much to worry about today. It's going to be one of them. Connor's up. I know Vince is probably up there. Storm Runner's up there. There's Vince. So if you want to watch storm development and learn more, watch these storm chasers out here and watch the structure of the storms on radar. That's the best, quickest way to learn. It's going to be about the same tomorrow. The same deal. We'll have some storms. It'll be random like this. They'll form randomly, more than likely along the bay or the Delmarva in the afternoon, around 2 to 3 o'clock, just like today, and out in the mountains again. However, tomorrow night, the rain will persist because a low pressure is going to be moving up the coast through North Carolina during the day, and it'll line up with these storms and start reversing the flow. So the storms will be moving west to east all day, and then around 8, 9 o'clock it'll start getting close enough to where it starts changing the pattern and pushing north, or pushing northeast back against the mountains, and it'll start squeezing the rain out of them. But it's still going to be the same level of storms, not severe. like we have been seeing in spring, it's going to be like today's level where they're still going to be capped off. They're not going to be, um, anything extreme or anything crazy. It'll just be barely able to reach the severe limit, and mostly just heavy rains, a little bit of hail, and some gusty 40 to 50 mile an hour winds with an occasional burst here or there randomly to 55 or 60, which can cause a little damage, but not like 70 or 80 mile an hour craziness like we had for Easter or anything like that. But I know you guys got some heavy rain from that storm, and it's falling apart right now, but it's probably going to flare back up. It's got another couple hours. So what happened is it's just rained itself out, and you can see it start to thin out, and it made a bunch of lightning, and then it stopped, and now it's getting real thin, but it's still hanging on. And the area that's causing that will start drifting to the south as well, so it'll move off, and you'll be able to watch it down over Assateague Island and then out over the ocean as the evening progresses. And once it gets out over the ocean, it might die out completely because it's cold water for a couple 100 miles until you get out to the Gulf Stream, and then they'll suddenly flare up when they get out about here, this far out. Let me close that down so you can see. Put this back together the way I had it. And you people that are on Facebook, if you want to talk in the chat but you can't read it because it's too small, you can jump over to the YouTube page. I broadcast simultaneously on both at the same time. So what you can do is go to Mid-Atlantic Severe Weather Alert YouTube, and it'll have the chat separate like YouTube does for everybody. And I can type in both at the same time, so I can still answer you and talk to you, but it's easier for you guys to see. But these are typical summertime storms. You can still see that sea breeze effect happening on the radar right there. It's real thin as it moves in. It usually starts out as the shape, and this happens all up and down the coast. That's what can cause water spouts. It can cause severe thunderstorms to just explode suddenly out of nowhere like they did today, but much worse. It just depends on the overall conditions. Luckily right now we have that capping high pressure to keep them from getting mean. Same thing out west. Capping high pressures, keeping them from getting too tall. But they are dumping copious amounts of water. Yeah, that's the Cannon Valley right there. So right to the side of there. The next valley over. Down in the Dolly Sods. Usually Morgantown's the one that get hit. But today, it's along the Alleghenies. So, just for a geography lesson, you can see these mountains pretty clearly on my radar here because I use a real map, a real image. All those striations are mountains and valleys. Here's Route 81 all the way up here through Chambersburg to Harrisburg, and then the first ridge line that you see is the Appalachian National Scenic Trail, the Appalachian Trail, Harper's Ferry, and that goes up through Boonesburg in between Frederick and Hagerstown. If you drive out of Baltimore and go out to the mountains, you're going uphill the whole way. By the time you get to Frederick, you're about 450 feet higher than you were at Baltimore City, Fells Point area, which is sea level. And then you go all the way up to about 1,890 feet, something like that, where that bridge is at the very top of the peak on Route 70, that first mountain. and then you go all the way back down to 500 feet in Hagerstown. And Hagerstown is in the Great Valley, which you can see clearly here. And that's between the South Mountain, Catoctin Mountain area on the right side, or the eastern side. And then you can see all this farmland and the river snaking along. See how it snakes left to right, left to right, left to right. That's the valley floor, the lowest point near Hagerstown, a couple hundred feet above sea level. And then it starts going back up again. And then you cross the top of the mountain here by Indian Springs and all that, Green Spring Furnace. And then you're at the top of the peak there by what is it? I think it's Green Spring, or no. This is it right here. When you cross the big valley and you go back up the hill on the other side, it's Cove Road, I think. Then you start going back down Big Pool, and the Potomac River has cut a path through there, right through the mountain. But all that area you can see there, North Mountain here, Hedgesville, Little Georgetown, and all these mountains here, you can actually see the power lines that they've cut across the mountains. So here's the peak of the mountain, right about here. So this is uphill, 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 2,000 feet more, back downhill, back downhill, back down here to the river. And then you're down in the river valley again. And it goes up again, up again. And then there's a whole bunch of small ones that you cross, and you can see the hills and the striations in the land and the valleys until you get out to Berkeley Springs, where 70 and 68 meet. And then you go across the Potomac there, and you've got more mountains in the Sleepy Creek area. One of my favorite places right there. Just one big long nature preserve. Mountains on the right side, big valley on the left. No houses or anything allowed to be built. You can see it. Look at that thing. That's one big mountain right there. Sleepy Creek Wildlife. Great Cacapon. So Appalachian Mountains are all through there, and then the westernmost edge of the Appalachian Mountains is called the Allegheny Mountains, and it's a steep area between the end of Maryland, Grantsville, where 219 comes out, and then it shoots straight up in the air along the mountains to Frostburg, back down again. And that's the Savage River Valley that flooded out recently. And all that water got focused down here from Frostburg, Cumberland area, down through the Savage River into Western Port, Kaiser, and all that area from both directions, and all the mountains act like a big bowl. So we're going to see flooding, is why I'm showing you this, because it's growing to the east towards Romney again. And if these storms form over Kaiser and up in here into Cumberland and like Lonaconine and all those areas, Western Port, they can flood back out again. So if you're camping out here this weekend, you need to pay close attention. So, because this is tropical level rains, and as Kyle's showing us there by Ocean City, it was a half inch a half hour is an inch an hour rainfall, and that's approaching tropical rainfall levels. 2 to 3 inches per hour is enough to cause instant flash flooding to the point where cars are stranded and people are being water rescued. So from 0 to a half inch an hour is okay, but flooding causes problems. But when you get faster rainfall rates than 1 inch per hour, it's quickly, exponentially a problem, especially on the Delmarva Peninsula where there is no drainage. A lot of people don't know this either, but this whole peninsula from 95 south all the way down to the Chesapeake Bay Bridge Tunnel, the highest points is called Still Neck Pond over here by Baltimore side of the bay, 105 feet. And then I think the average height is like 35 or 40 feet on this whole peninsula. Everybody that lives on the Delmarva Eastern Shore side to the beaches, 35, 40, 45 feet average. As you get up towards Middletown and further north into Newcastle County, it quickly rises because of the mountains, but it's weird how that works, where from the canal south, the C&D Canal south, I don't think there's anything higher than maybe 45, 50 feet, and the highest points are man-made overpasses and bridges. So let's see, is this going to do this again? Let's shorten up the frames, keep an eye on it. Looks like just south of Chincoteague, down there by Wallops Island, where the Space Coast is, our new Space Coast, is getting hammered from the same effect. But as you can see, these storms keep forming. There's more on the way, so Kyle, you're not done yet. You'll probably get more rain today. That line will keep forming and moving offshore, but it's going to keep drifting south very slowly through the evening as well. So it'll move off of you probably by sunset. And you'll get random lightning strikes, unfortunately, over the next couple hours. So be careful going outside. Let me pull this camera up. There's a lot of cams in Ocean City that you can look at, and they're good for weather. There we go. So here's a good cam on this page, OC Maryland webcams. Let me put that down. This is the tower cam looking south, so we're looking at the storm. I'll make that large. So we're looking about 90th Street down towards the inlet. Bay is on the right side, ocean and beaches on the left side. So the boardwalk starts about here and moves down, and you can see in the distance there the storm, just rain, and it gets fuzzy and you can't see the end of town. So if I were to place this camera on the radar, we are about right here. I'm looking this way. So that's where we're at in Ocean City. We're about a little bit north of Route 90, looking south towards Route 50 and the inlet. I'll move that over here. I'll put this next to it. and we'll check some cams. So that's a cool shot. And that's live. Now, dozens and dozens of choices. Here's down by the boardwalk. You can see it's raining. Not many people out right now, but everybody's on the way. Just got done raining hard. And this is up further than I remember. There's another one that's down. Here's the Ripley's cam, where the big shark is and all that. Not many people out. It's still early though. So this would be where the Atlantic is. Okay. So that's probably like Dorchester or Talbot. I used to live down there. Plym Plaza cam. Looking back south. More people up that way because it's not raining. So the further south you get on the beach, the thinner the crowd gets because it's still raining down that way, but it's drifting south. So it's pretty much done raining now from the inlet south. And you can see the skies are clearing up. So we've still got an hour or two before it starts getting crazy. But you can watch these cameras live and see what's going on down there. It's pretty cool. You can see a lot of stuff like that. There's even further down on the boardwalk by the pier. So there's like nobody down here by the inlet. That's crazy because it's still been raining hard. They're just kind of opening things up right now. This is right by the entrance to the pier. It's probably going to be raining off and on, so for the air show especially, they may stop it for a little while, but it's going to be hit or miss like it is now. You're not going to have like a horrible time or anything, but they may have to stop it for a little bit for a storm. Looks like that's out. Looks like they're just now starting to set up for the air show. With the big stands and speakers and all. Not a lot of people there yet, so I know traffic was bad earlier. Definitely check traffic. It's going to be crazy. And man, there's like a million cops out everywhere today. So they are definitely looking for people to pull over. There's Assateague Island cam. That's what I was looking for. So yeah, you can see the storm in the distance, real low to the ground. It gets hazy real quick, but see how low the clouds are? They're like right at the surface of the ground. But it's clearing off now, so you guys should be alright tonight. It may be another storm that fires up. But I'm going to hop off here. There's nothing really else going on. these cells will keep popping up further and further south. And the same thing will probably happen tomorrow afternoon. Randomly, they may be up north further or down south further. So pay attention to your promoter's webpage for the air show and whatever official sources are. Figure that out tonight so that you know where to get your information from most accurately. And don't trust the rumors online. There's going to be a lot of bad information where people are going to be like, oh, it's raining here, it's canceled. They don't know if it's really canceled or not. They just assume it. And then everybody thinks it's canceled. And they miss it. So always just go direct to your official source for the air show webpage and use that for your information, because they may not cancel it. I doubt they will, honestly. Now, storms are starting to get a little closer to our side of the area where we've got the I-81 corridor. Storms are starting to make their way across, so we may get some small storms. Like I said, later in the evening, this energy, this line of energy, is going to be drifting to the east as well. And when it gets out of the mountains and over the Frederick, Carroll, Howard, Montgomery County areas, probably we'll see flare-ups again in the evening, but nothing more severe than we've already seen. It's going to be heavy rains. Heavy flooding rains are the biggest threat tonight. Same for tomorrow. Nothing extreme or severe. No widespread tornadoes, but lightning, and then obviously lightning is always the biggest concern when it comes to any storms. People standing out on the beach for air shows and stuff like that. We don't want that to happen, but I'm hoping we get the same kind of pattern here tomorrow, where they flare up quickly during the afternoon, and then by an hour or two later, they have not moved far, and they are no longer generating lightning, or very little. So it looks okay. Alright, I'm going to hop off here, and if anybody has any questions, just hit me up on the Facebook Messenger, and I'll try to get back to you.